Hello everyone, welcome to my channel. Today I'm going to talk about another live screen recording of coding for another classical problem. Remove the nth node from the beginning of a linked list. For example, we have a linked list 1, 2, 3, 4, 5, and we have another number n, so I want to remove the second node of this linked list. Here n starts from 1. So in this linked list, we will remove the second one, which the result linked list will be 1, 3, 4, 5. This is another example. Well, we have a linked list of 1, 2, 3, 4, 5, and we want to remove the first node. So the end linked list will become 2, 3, 4, 5. In this example 3, we have input 1, 2, 3, 4, 5. And we want to remove the fifth node of this linked list. So the tail is removed. The output should be 1, 2, 3, 4. The n can also be embedded if it is bigger than the length. For example, the linked list has 2 elements and we want to remove the third element. So the third element doesn't exist. So we should keep the list unchanged. Now let's look at how to do this problem. So it's kind of, in the normal case, if the node is in the middle, it's a bit straightforward. All we need to do is try to find this node and also to call the previous node and connect the previous dot next into the current dot next, and then this node will be removed. It will also work if this is the tail. For example, here, the current node will be 5, and the previous node will be 4. Oh, not this one. In this remove tail case, the current node will be 5, the previous node will be 4, and when we connect 4 dot next to current dot next, which is now, then the tail will be removed. It's a bit tricky if the head is removed, because for the head, there's no previous element. And then one way to do this is to have some special logic to check if it is the head. If it is head, if n is equal to 1, we just return head dot next. If we want to be consistent, there's a common pattern in the linked list handling is we have a dummy head, and then we don't need to handle this specially. And how to find the current node? So it's also kind of straightforward. We can set the I start with 1 and compare with I versus index. If I is less than the index, then we move 1 step forward. When I is equal to the index, stop processing. So we can stop. So first, let's handle this edge case. If n is less than 1, return head. And here we can choose to do a special logic for n is equal to 1. Put 1 head dot next. And now we will see this node. It has C I is equal to 1. Is equal to R. Path. And I equal to 1 while I less than n. C I is other next. A Platon. So in this case, if I is equal to 1, A will be correct. Current is pointing to the head node. When I is equal to 2, so current will be moving to the second node. So it is also correct. In this case, head is moving to the current is moving to the correct node. When n is 5, So we'll do initially current is head, and then we will I is equal to 1, and when I want current to move to a certain node, I will be 2. So so every time I is matching with the current node. So when I need 5, current node is pointing to node 5. And then we will have the previous nodes. So in this case here, EV is now, initially it was now. And every time when we move one step forward before we assign the new value of current, we will set the keep track of the previous equal to current. So at the current move to the next, previous will be the previous node. So in this case, previous dot next equal to current dot next. So this also works correct when current is a tail node. So 4 will be pointing to the nav. In this case, we can return the head. But it is also another edge case when n is bigger than the length. So here, we also need to check that current is not now. Otherwise, like we'll got an NP exception. So here, what we're seeing is if n is 5, current should be 5. So when n is 6, current will be now, and the previous will be 5. In this case, when n is 6, it will be invalid. So what we can do is if current equal to now, we should return head. Because in this case, current will be now, so this line will got an NP exception. If we don't do this special check. Now let's run this program. Oh, we got a failure here. Let's see. I think it's also possible that like pad here post would now have the head. We can because its list sign can also be yellow. So let's try again. Okay, now we have passed all the test cases. We can also try to run these random test cases. All the test cases have been passed. So let's look at this again. So first, we need to check the edge case, if the list is empty or if n is less than 1, then we just return a head. If n is equal to 1, we can return head down next. Now we're trying to find out the current node, the nth node. So we try to see, okay, the current is try to match I versus the index n, and try to make them the same. And in this way, the current will be pointing to the correct node, like 5 here. So we also need to do another edge case check when n is greater than the list dot length. So in those cases, current will be now here. So we need to make sure, like in this loop iteration, we also check current is not equal to now. When this ends, if current is now, this means like it's bigger than the list dot length. So in those cases, we return a head. And when we are both valid, we just return make the previous dot next equal to the current dot next. I think the key thing is A is the during the loop, we want to make sure that it will not got the NP exception. The second thing is that every time we assign the new value for current, we make sure like previous is also updated properly. And every time when we iterate, we make sure current is also moving properly. So every time the iteration, we make sure like all the state is updated properly. There are also some other implementations of this problem. We may talk in the future videos. These are like very this is relatively an easy problem, but this is a building block of some more complicated problems. For example, a relatively more complicated problem is remove the nth node from the end, but that will involve several different steps. But I think it's a good idea to practice the basic to remove the ends from the beginning, and then like try to solve those like more complicated problems later, because a more complicated problem is combining several different steps of easy steps. So it is good to like practice the building blocks here. Thank you. If you have any questions or comments, welcome to comment in this video. If you like this channel, welcome to subscribe. Thank you.